This video is going to go through the handout for chapter 17.1, where we're looking at how we handle statistical inference when we have two categorical variables. And the example we're looking at is the Census Bureau's American Community Survey surveys a random sample of 5,000 Americans each year to learn about the state of health of all Americans. And one of the questions they ask is, do you have health insurance? And in their 2008 sample, 17% of respondents reported that they didn't have health insurance. And in 2016, 10% of the respondents were uninsured. So what we want to try to figure out is there a difference in the proportion of all Americans that have health insurance between 2008 and 2016? And the very first question wants to know what our parameter of interest is. And when you're trying to determine what the parameter of interest is, it's always helpful to figure out what type of data you're working with. How many variables the question is asking, and what type of variables are involved in answering the question. Well, of the information that they're collecting in this question, there are two types of variables, and it's always helpful to read through the question twice. First time to get an idea of what the question is looking for, the second time to get a little bit more of the specifics. So it says that this survey company randomly samples 5,000 Americans each year to learn about the state of all health of Americans. And in 2008 versus 2016, so the year that the survey was conducted is one of the variables. In our case, the year is going to be categorical since there's only two of them, 2008 versus 2016. And that's going to be our explanatory variable. That's going to be the one that divides the data up into the different groups. And then they're asking each person if they have health insurance or not. And when you're trying to figure out what the variables are, you want to remember, what are they getting from each individual person or each respondent? And one of the questions they're asking them is, do you have health insurance? And the answer is either going to be yes or no. And since it's a yes or no answer, that's going to make it categorical. And what we are looking at is the difference in percentages of people that are insured or not between 2008 and 2016. But those percentages are the summaries. Those are the statistics themselves, not necessarily the variable. The variable is what you get from the individuals. So what is our parameter of interest when our explanatory variable, which is the year, because that's what we're trying to see, compare the two different groups, 2008 versus 2016. So the two groups we're comparing is our explanatory variable. That's categorical. Our response variable is whether or not they have health insurance, because that's the variable we want to compare, which people would either answer with yes, they do, or no, they don't. That one's also categorical. And when we have two categorical variables, that's going to determine our parameter of interest. And if we look through the slides, when we're comparing groups, it's going to require two different variables. One variable is going to determine the groups, and that's always going to be a categorical variable. So if you think of it as the 2008 and 2016 survey as our entire sample, what the explanatory variable is going to do when it's categorical, which is the case that we have here, 2008 versus 2016, is it's going to essentially divide our sample up into groups. So we're going to kind of, in this case, since it's 5,000 each, cut it right down the middle. One side will be group 1, the other side will be group 2. And essentially what we're going to do is, instead of working with one large sample, is we are going to split them up. We'll move group 1 over into their own group. We'll move group 2 over into their own group. And then once we split the data up, we're going to find the same statistic for each group. We'll calculate the proportion of people that were insured for group 1, the proportion of people that were insured for group 2, because our response variable was categorical as well. And the response variable is the one that you're going to summarize. The categorical variable here is our explanatory. That's the one that its goal is to divide the groups up. And then our response variable is what we're actually going to analyze. And we talked about in chapters 2 and again in chapters 13 and 15, when you have a categorical variable that you actually want to analyze, you summarize it with a proportion. So what proportion of people in 2008 had health insurance? What proportion of people in 2016 had health insurance? And then essentially we're just going to compare them. When we have two categorical variables, our parameter of interest is going to be a difference in proportions. P hat is your sample proportion. It's what we actually have information on, but our parameter of interest is about all Americans. And so this P16 is going to represent the proportion of all Americans that were insured in 2016. And this P08 is going to represent the proportion of all Americans that were insured in 2008. And then our parameter of interest is how different they are from one another. So we'll just write that it's the difference in the uninsured rate of all Americans between 2016 and 2008. And the problem is we don't actually know this number because we don't have the information on the entire population. Each year we just have information on 5,000 Americans. 5,000 Americans is a lot, but there are about 300 million people in the United States, and 5,000 is well short of 300 million. So we're working with a large sample, but it's incomplete information. So we're not going to know what this P16 minus P08 is. But we can try to use statistical inference to learn about it. And that's essentially what we're going to do in questions 3. We have part A through E is we'll conduct a hypothesis test to try to see if the proportion of Americans were uninsured in 2016, 2008 is different. But anytime we're going through and doing statistical inference, it's always a good idea to write down what you know about your samples. And when you're working with a categorical variable, you want to write down your sample size. The sample size N for 2016 was 5,000. And the sample proportion in 2016 was 10%. If you write it out in proportions, that'd be 0.1. Do the same thing for 2008. The sample size then was also 5,000. And our sample proportion in 2008 that were uninsured was 17%, or 0.17. That's our information. And then we want to know, are these two percentages different enough that we also think there's a difference in the populations as well? So question 3 says, were fewer Americans uninsured in 2016 compared to 2008? And since we're asking a yes or no question, if we're going to answer this question, we either say yes or no. Yes or no questions, we answer them as statistics with a hypothesis test. And step 1 of any hypothesis test is you want to state what you're testing, what your default assumption is, and then what you need evidence of. So our default assumption is that anytime we're comparing two groups, it's always a good idea to assume that they're not any different from one another. And that's what our null hypothesis is always going to be. Regardless if it's categorical or quantitative, we'll just assume the two groups are the same. Which in our specific question is that the uninsured rate is the same in 2016 as it was in 2008. That's how we would write it out in words. If we're going to do it in our statistics notation, we just say that P, the population proportion of uninsured people in 2016, is equal to the proportion of uninsured people in 2008. And we'll just assume that it hadn't changed at all. And then specifically, we want to know, were fewer Americans uninsured in 2016? So that means our alternative hypothesis is going to say exactly that. The uninsured rate is lower in 2016 compared to 2008. Using our statistics notation, the proportion of all Americans that were uninsured in 2016 then should be less than the proportion of all Americans that were uninsured in 2008. And again, this is always the most important step because that's going to dictate a lot of what we do later on, is you want to determine what your null and alternative hypotheses are. Once you have that, the next thing you want to do is check your conditions. And 2 of the 3 conditions that we're going to have for this test are going to be the same as the ones we saw in chapters 13, 14, and 15. We need independence within each sample, and we need a large enough sample size. But now that we're comparing groups, we're going to add an additional condition that we need to look at, and that the groups themselves are independent. So let's start with the 2 that we've had since chapter 13. We need the people that we're sampling within each of those years in both 2008 and 2016 to be independent of one another. And one thing we need to look for is randomization. You can either have random sampling or random assignment. Either you take a random sample of the entire population or you do a randomized experiment. In this case, you can't randomly assign people to live in a certain year, but they did take a random sample of 5,000 Americans each year. So both in 2008 and 2016, they took a random sample of everyone. That means we can check off our randomization condition. And since there are a finite number of people in the United States, we want to make sure our sample size isn't too large. And we'll check our 10% condition. We just want to make sure our population is less than 10, our population is more than 10 times our sample size. So we took a sample, or they took a sample of 5,000 people, multiply that by 10, you get 50,000. There are more than 50,000 people in the United States, both in 2008 and in 2016. You have to check that for both years. So then we meet our 10% condition. So we can check that one off. That means it's pretty safe to assume that the people within our samples are independent of one another. An example where they wouldn't be independent would be if you sample households and ask each person within the household, are they uninsured? If a wife is uninsured, their partner is also likely to be uninsured. That builds a dependency. But if you're just picking people completely at random, the chances you happen to pick two people who are married to one another is really, really small. So we can assume that our people within each sample per year are independent of one another. They're not going to influence each other. The next thing we want to check is to make sure that the two groups we're comparing are also independent of each other as well. Meaning, if we surveyed Bob in 2008, we wouldn't want to survey Bob in 2016 as well. And the easiest way to check to see if the two groups you're comparing are independent of one another is just to check if they took two separate random samples. If there are 300 million Americans and you sample 5,000 people, the chance of picking the same person in both 2008 and 2016 is really small. So as long as we take two separate random samples, the people we pick in 2008 doesn't influence the people we pick in 2016, then we can assume the groups are independent of one another. And they said they took two separate random samples, so we can check that one off. We have independence of each sample that they took. The samples themselves are independent of one another, meaning the people who they surveyed in 2008 doesn't influence the result of the people who they surveyed in 2016. And then the last thing we just want to make sure is our sample size is large enough, meaning for each of our samples for both 2008 and 2016, you want to make sure that there are at least 10 people who had health insurance and 10 people who didn't. So we'll just take our overall sample size, multiply the proportion of people who were uninsured. 5,000 times 0.1 is 500. That's more than 10, so we can check that one off. The number of people who do have health insurance, because our number of failures in this case is going to be the people who do have health insurance. Since the question is asking about uninsured people, an uninsured person is a success, an insured person is a failure. Generally, it's a little bit backwards, even though you probably don't want to think about people as successes and failures to begin with. But we'll take our sample size, multiply it by the proportion of people who had health insurance. If 10% of people had health insurance, 90% of people don't. 5,000 times 0.9 is 4,500. That's greater than 10. So in 2016, our sample size was large enough. We'll do the same thing in 2008. In 2008, 17% of the people surveyed didn't have health insurance. So we'll take 5,000, multiply it by 0.17. That's 850. That's greater than 10. And then we'll do the proportion of people who did have health insurance times our sample size. So 5,000 times 0.83, we give you 4,150. 4,000 is more than 10. That means we meet our sample size condition as well. And so we'll pick up the rest of this handout in the next video.